in the chat. Don't forget to sign the attendance. Okay, I think we are going. Okay, boom. Okay, boom. Okay, so can somebody just check the YouTube video for sound, just for audio? Just that it exists is the king. I will. You're like, well, hey, Dr. K, how about the bloody link? Okay, here we go. There's the link to the streaming right now. So seeds, what? Yeah, I'm with Craig. I think on the triggering, man. This is like somebody just dropped an actual taco just inside a book and just put it in the book drop. What the hell is wrong with people? Really, what is wrong? All right. So William, you've got audio, no sweat, right, William? And if you're on YouTube, you got that sort of 5 to 10 second delay, unfortunately. Okay, so here's what's cool. So, hey, welcome everybody. We're a little shy on numbers. Some people getting an early jump on spring break. No doubt. Let's see. First thing I wanted to just hit on, let me get this over here on the big screen. Yeah, blow it up a little bit. Okay. Yeah, so we got 1, 2, 3, 4, 5, 6, 7, 8 weeks. We are 8 weeks in, and next week is spring break, which means we are at the halfway mark. That becomes 9. Then we come back with 1, 2, 3, 4, 5, 6, 7 weeks to go. So we got 8 weeks down, 1 week freebie, and we come back with 7. And one of those I'm going to try to be gone, which would be the first week of April, if I can manage that. Still trying to figure that out. Anyway, so spring break, hopefully an opportunity for everybody to catch up on everything, not just here, but everywhere. Any hot takes? We were talking yesterday at length in 305G about Ukraine and about the role of technology and social media, that sort of thing. And it's phenomenal. It's amazing. I mean, obviously, by phenomenal, I just mean the impact of social media, sort of technology on the ground, and the role of technology in folks in Ukraine and the victims of that whole stupid situation. Anyway, it's a little off our topic here, but anyway, I wanted to just a little shout out. Just it's yet another thing, and I haven't actually hit any headlines since this morning, so I don't know what's the latest and greatest coming out of Ukraine right now. I haven't really checked since this morning. So, but what we want to talk about today, wait, today's the 2nd. Yeah. No, we're at class diagrams. We're good. Um, so Gunnar, explain what that is. Um, Tyson, I think that Putin has said words about why he's invading Ukraine, and they're all like, you remember when you had like an older sibling, or maybe you were the older sibling, who would grab your hand and start punching you with it and say, "Stop punching yourself! Stop punching yourself!" It's like that. To me, it's a comparable level of common sense and logic. You know what I mean? It's all like gaslighting on a world stage. You know, does that make sense? There are other motives and other reasons why, and who freaking knows? I certainly don't. Okay, what I wanted to do was pull up. Um, Mike, is that true? That's not actually true. Is that like really true? I mean, there's a difference between you hit a few targets and you know what I mean. If is it overfitting? The sincere question, Mike, is he overfitting? Are you overfitting the data? You know what I mean? Yeah, right, right. Well, yeah, and one of the things that happens is, of course, everything gets bloody stupid, right? Like really, really fast, you know. And Gunnar, I saw articles about that as well, about the convoy. Yeah, and I agree with Wes. He's gonna rattle his nuke saber. My own belief, based on I'm just a guy, right? I have no expertise in this area. Not no more than any of you. Well, probably more than some of you, by by virtue of just being alive for a while. But you know what I mean? Not really, not in practice, uh, and no, specific education. But I don't think there's a chance in hell that he would actually play that card. I really don't think so, unless the advantage that a sort of a sociopath you know has in any confrontation is that they will not follow moral rules, right? I mean, if he fired a nuke somewhere, do you really think that Biden would say nuke the entire Soviet Union? I doubt it. I really don't think so. So I think maybe he's like, well, we can play three nukes before the other side retaliates and still use one. I think he's crazy enough that that's not outside the realm of possibility. But on the other hand, if he believed that the other side was, I feel like I'm going to make a bold statement that's really outside our subject matter. I think the one advantage, I'm not a Trump fan, not a Biden fan either, right? So I didn't vote for either of those two guys. Um, but I think one of the advantages that we had when Trump was president was that anybody crazy on the other side of the equation, like Putin or Kim Jong Un, had to know that maybe he was just crazy enough as to be like them. I mean, he might respond. I'm not trying to, Trump supporters, please understand, I'm not trying to say Trump is Putin or Trump is Hitler or Trump is Kim Jong Un. I am saying that he's a little bit of a wild card and a little crazy. And I think there's at least the potential that somebody who's crazy on the other side just goes, I don't know what the hell that guy's going to do. And that's destabilizing, where I think that there's a higher propensity to say, I think I know what Biden's going to do. That's all I'm saying. That is all I'm saying. Talk to the hand. That's all I'm saying. I'm not trying. I am not trolling. Okay, I am. I swear to you, I'm not trying to troll. Yeah, actually. So seeds. Yes, the truth is, I actually do despise that guy. I hate's a little strong, but I despise the guy. So I'm not in denial about that. But I was, in fact, trying to make a different point. All right. Yeah, Craig, don't reveal your power level, please, please. Let's wrap it up. Let's move on. Let's get over to. I wanted to. Did I play for you so we had the one day with no audio. Did I attempt to play video on that audio? But most of you were here live. Um, yeah, Riley, I'm not sure if that's true. I wish that was true. I wish that was true. I don't know that that's true, but maybe somebody. Um, okay, let's talk about class. Should we talk about class diagrams? There's something boring. You know what I mean? We're all like perched on the verge of World War II, and we're like, class diagrams are so important. Doesn't it feel like that a little bit? Like, come on, what are we doing here? Okay, my system's being slow again. Where am I? Where the heck am I? Yeah, so how's the audio now? Is it coming back? Because I think I went into like stutter mode just moving my mouse. And my guess is everything. Yeah, James, as soon as we started talking about class, as soon as we got on topic, audio's like, no, I'm out of here. Is it getting any better? Is the audio any better? Because I had a point where my mouse started going jiggity jiggity, and I think my whole system was kind of grinding. Yeah, James, it was hackers. It was you guys hacking my laptop, playing hacky sack with my system. Okay. Anyway, we know where we're at. I'm excited because we are past the halfway point, and that is exciting. Okay. Hang tight. Did we finish use cases? I feel like we didn't. Anybody remember? We did? Got to the very, very end, James? Are you just saying that because you don't want to talk about it anymore? Okay, hang on a second. Hang on. I'm being slow. My audio should probably go jiggy now here for a sec. I'm just scanning back to the end of the slides. You are correct. No, no, no. No, yeah, you're correct. We did get through. We did get through all of it. Okay, let's get over to class diagrams. Just trying to open PowerPoint right now. Being slow. I actually rebooted my laptop before I started class. That's how suave I am. But sometimes you actually it's a slow to kind of load if you've had operating systems so far to get, kind of an active set of pages in your memory. Which having, gotten to a certain level of saturation, things move a little slower because you're not pulling things out of hard drive. Um, okay, Wes, I will watch that later. And you gotta edit the spelling on groaning because you're killing me. Look it up, and do an edit. You can edit what you write in Discord. But Matt Groening is a time traveler, and I think the evidence is, even without whatever that is, the evidence is already compelling that for Matt Groening as a time traveler. No, come on, man. Gunner, you're killing me. Wes, fix it. I beg you. I beg you. Okay, where are we at here? I'm still waiting for my stupid PowerPoint slides to load. So, Wes, are you gonna throw me a bone here and edit that thing? Okay, there we go. Wow. Wow, that was just really slow loading. Okay, let me get into this because it's so important. Again, when these kinds of things happen, I felt the same way 2 years ago when when the whole COVID thing hit and we wound up swapping to online in the middle of spring break in March 2 years ago, and everything just kind of stopped feeling so bloody important, you know? Um, mm, there we go. Thank you, Wes. Much appreciated, Matt Groening. What is that? It seems like that's a Dutch. It seems like a Dutch name, so you get that. I don't know how to pronounce that, but I'm going to bet that's a Dutch surname. Okay. Yeah, so hey, here's some slides. How about let's talk about them. We'll try to roll through. We'll try to, get some value for you for y'all's tack on to your patterns, your head first. Oh. Hang on a second. Who are we having the conversation with in class? So important of a book to me that I keep it right here. No, it just happened to be there. Um, and somebody was trying to figure out who the skater chick was, right? Who was it that said that was Seeds? I know who it is. I figured it out. It took me about 5 minutes after class. Okay, in the book, and you know the one. This is the skater chick book, as I like to call it. Um, you see right there where it says cover designer. Cover designer Ellie Volkhausen. Ellie Volkhausen is the skater chick. The cover designer is her. She is the lead singer. She was a graphic designer, cover designer, that kind of thing. She also is under the stage name Ellie Vee. There she is. There she is. Um, she is the lead singer of a band. But isn't that her? Isn't that her? I mean, scout it, man. Is that or is that not her? If you look at the picture that Mr. Seeds just posted. Yeah, Gunner. Um, no. It's Volckhausen. So Volck. Yeah, everything's correct, Gunner, except CK. Yeah, man. Look, you guys gotta, Tyson. You gotta brush up on your Google search skills, man. Yeah, there you go. There you go. Yeah, lead singer in a I don't know what kind of band. I didn't scout the music. What are they called? What are they called? Something I can't remember. It was Monday. Something like the charms or the something charms or something. Something I can't remember. These are the kinds of important, questions that occupy our minds and our times. Anyway, there you go, Tyson. No, no, I didn't find it in the book. I followed my intuition that there might be. So I want to be clear here, Tyson. I didn't like find in the book the answer to the question, who's the skater chick? What I found in the book, I went to the book to see if there was any citation or acknowledgement. And I found that the cover designer was Ellie Volkhausen. So then out of curiosity, I just Googled Ellie Volkhausen and, saw basically the skater chick fronting a band and, persuaded myself that, that was her. And I'm not 100% sure, but I'm like 98, 9% sure. So, okay. So Tyson, you weren't quite bright. Yeah. Well, it was my first instinct to just see if there was any crediting anywhere in the book. And I didn't even do a thorough look. This is so unimportant, as everybody knows. There's usually sometimes stuff in the back as well, um, where they'll, cite something, you know what I mean, in the credits. So, you know what I mean? Like, or in the acknowledgments, we'd like to thank Ellie Volkhausen for, whatever. Anyway, isn't that important? You bet it is. Darned important. Um, okay. What else? Yeah, anyway, that one I was reminded. Um, okay. Let's talk about some class diagrams, and then we got to save a little room at the end for some Norton. Norton. Why do I say Norton? Norman. And if any of you have sort of Norman doors or Norman things that are that you'd like to share, I mean, please bring those because it's fun to drop those into the mix. Okay. So let's see here. Class. Everybody knows what classes are by now, right? I mean, I was a generation that grew up in a world before object-oriented design and programming. I grew up in a world of what we call imperative programming. Essentially, it's the imperative model is I'm going to tell you how to do what you do. The ultimate classic imperative programming language is assembly language. The true kind of, I don't know what you want to call it, the ultimate classic high level language is probably C as a imperative programming language. So, it's like everybody can talk to all the data. There's no encapsulation. And with an object, with objects, class diagrams, classes became a thing, classes and objects. So I want to just I know you guys are heavy on the third culture kid thread, but if I could pull you guys off the third culture kid thing, I want to ask you a question, which is if you had to, somebody shows up from another planet, let's say, or they're not technical, they're not programmers, they don't have your training, and you've got to explain either object-oriented programming or an object class slash an object. Let's start with one differentiation without getting into object. How would you describe the difference between a class and an object, real quick? Kevin, nothing came through on audio from you. Just FYI. So calm your heart, Kevin. There was no embarrassing audio coming through. But don't you hate that when you're like, I've done this, right? You look down and you're like, oh crap, I'm not muted. What did I do? Did I burp? Did somebody scream? Um, yeah. Okay. So Kevin said class is structure. Ali said blueprint versus instance. Ooh, okay, I like both of those. I like Ali's quite a bit. Wes admits honestly, not sure that he knows the difference. That's fair. That's why we're here. Um, Lance said a description of an apple versus an actual apple. Yeah, Kevin asked, where does instances fit here? So, yeah, the way that I would look at this, so I think you're kind of, yeah, so okay, so Kevin said all objects can be classes, but not all classes objects. I think that is I'm going to go bold here, but in my view, it's a so with all due respect, Kevin, um, I know I did just solid on, telling you had no audio problems, but I think the argument doesn't hold for me anyway, um, because I think it misses a key relationship. Because when you start to talk about all dogs are mammals, but not all mammals are dogs, usually we use that language. And track with me, Kevin, see if you're buying. Um, but usually that shows up when you're in kind of a superset subset, right? Relationship. And objects and classes, in my view, don't partake of a superset subset relationship. And that's why I think Ali's comment, if I have I'm trying to come up with an example here. Um, let's see. Well, it's a little bit like a picture of a phone and an actual phone, if that makes sense. The picture is the class is the blueprint. It's the description. It's like the declaration of a variable. Okay. I'm looking at what Wes just posted. No, so Kevin, no, I think your understanding is slightly off. An object is an instantiated class. The class describes the object. Okay? So the difference would be, and if you back it all the way up to just whatever, Python, I don't know, Python's not a good example. C, something, C++, but irrespective of the object-oriented idea, just a variable, okay? If I write in my code and I save the code, and in my code I talk about, the code says that here's a structure, and then I do a new or whatever the command is to make a new one of these structures, right? Then I say new that structure. I can compile that. I can write it. It's in the code. I can compile it. But when I finally run that instruction, memory is allocated with that sort of known structure. And now I have the actual variable live in memory, whereas before I only had a description of it. Okay? So it's the difference between a declaration. When I write the code, I'm declaring, but until it runs, it's not actually, data. Okay? Does that make sense? No, the class, no. Um, so Wes said if a class is a marker, then an object, who brought up marker? Um, Wes said if a class is a marker, then an object is using that marker. No, I think you got to start with this idea that a class is the blueprint for a house. I can build that house 100 times down the same street if I want to, using the same blueprints. Okay? The class is the blueprint, the house is the object. The class is a description of an object. And I can instantiate the object by building the house. okay? Or by running the code that instantiates, the declaration. So the class is the blueprint or the description, and I use it in a number of different ways. But when I instantiate it and I make it come alive by making a new one, it comes alive. The constructor runs. Memory is allocated. Stuff happens. Right now, I have an object, and if I do it again, I have another object. If I made a linked list of the same object, I would use the same class over and over and over again, but I would have an object, and then that object would spawn a new object. They would be connected, and that one would spawn an object, and they'd be connected. And I'd have a linked list of objects, one class, because that's the description of all of them, but a potentially limitless number, conceptually limitless, right? Not practically limitless, number of actual instantiated objects. Okay. Now, the reason that I asked that is I want to make sure that you have. When we get into class diagrams, use case design is programming paradigm agnostic. Okay, it's paradigm agnostic. You don't have to care much about what you're doing, because use case design is still right. You've got this system, you've got a wrapper. I can talk to it, look at it, interact with it. I don't care about object-oriented anything. But I want to just start with this notion, because some of the diagrams that we are going to be talking about relate to classes. They relate to the declaration, the description. So the class diagram tells you what an object can be like, but it doesn't show you the actual configuration of the objects while they're running. Okay, does that make sense? It's kind of like the difference between a blueprint of a house and a photo of a street of what we sometimes would call row houses, or just, what do we call it? The burbs, the suburbs, you know what I mean, with the same stamped out, exact same house, right, down the street. A photograph of those houses is more like an object diagram. The blueprint that you use to build any given one of those houses is a class diagram. Okay, so I want to make sure you understand that. And I know you've had this in classes, but maybe that differentiation didn't quite stick. You know what I mean? So let's stop for just questions. Do you feel like I'm going to do this? I'm going to make a survey. Survey. I'm just typing it. The survey says, after that discussion about classes and objects, I think I have a clear understanding now. And I'm not going to look, so we can shame anybody who says no. If you're really a no, just say no, and it's just helping me to calibrate. And Anthony, thank you. It's when we're going to start talking about object-oriented design, we ought to be clear about what we mean when we say objects and when we say classes. I'm going to do one more survey. Okay, next survey. So 17-0. Thank you. I think it's an important starting point. The next one. This is just to try to gauge. And by the way, a no means probably I already really understood it. It was fine. It reinforced. It didn't really give me anything more because I really did kind of already understand it. Is what no means. Okay, I don't think I don't think it's wasted, but we're running about 50-50. So that's good. I'm just trying to gauge whether we were wasting our time. I know we were wasting our time with some of the earlier topics. Um, right. But for those that are, just trailing a little bit, you know how there are, I remember, man, programming professionally in C and not really understanding how pointers worked in C. Just remember that in my 20s. And then there was a point where I was teaching a class on C or something, and then I had to teach it, and then I had to actually understand it, and it made a tremendous difference. Um, you know what I mean? It really made like a huge difference to have to teach it and then get my understanding more clear so that I could understand, that I could describe it. That's part of the reason I'm asking, initially, tell me what your understanding is. Okay, so you understand that, and if you didn't before, you do now, that a UML class diagram is like a blueprint. Now that's sort of principle number one that I want to make sure that you understand. Principle number two, and I'm going to ask it as a question, which kind of was how I started. When you, if you tried to explain object-oriented programming to somebody who had maybe just like somebody like me back in the 80s, 90s, actually, was when I really encountered object-oriented programming. But, somebody that had only ever programmed in C. I had professionally programmed in C and in Pascal by the mid 80s, by the mid to late 80s. But, no object oriented, no C++. There was no Java till the mid 90s, right? You realize that. I was, you know, pushing 40 when Java showed up. That's how new Java is. How would you describe it? What's the punchline? Now I have the advantage because I've been teaching for a long time, and you kind of you sort of like have to come up with ideas and ways of explaining. So I definitely have the advantage. That's not fair, but I want you to have the thought exercise, thought experiment. Um, what's the punchline? Like, why do I need object-oriented program? And if you're just like, well, because you can build cool systems. I could already build cool systems. Why do I need it? You got to distill it down to what is the essential, which is actually a pattern. Okay. And in my dissertation, in my PhD dissertation, I actually did, I had a, hmm, it's a bold play, but I actually wrote a pattern in my dissertation, um, for object-oriented programming, like a pattern of what is object-oriented programming. Should I go grab it? It's just in the next room. I'm going to do it. I'm going to do it. But drop your comments. Drop your comments about what you think it is. Then I'll go get the definitive answer. Hold tight. I have the headphones, the headphone units in. So while I'm walking down the hall here, I can um, still talk to you. And I got to try to find it. Where is my dissertation? I have a Mondo bookshelf. It's possible that it's in my office on campus. No. Yeah, I think it's in my office on campus where I am not. Um, but I think I have a soft copy. Yeah, no, dang it. I mean, it's a little classic to, I'm coming back. I'm coming back down the hall. I think it's a little bit classic to go with the hard copy, But I think I've got a soft copy PDF. somewhere. I mean, it was the 90s, you know. Okay, let me look it up. Sorry, I'm looking. This just came to me all of a sudden. It's not like I wasn't planning on this. So, hey, okay, got it. We'll see. Maybe it sucks, right? Maybe I suck. I don't know. You be the judge. All right, 309 pages. All right, James. I'm going to just see what you guys said first. James said, explaining it to someone that doesn't know OOP but knows programming. An object is a repeatable collection of variables and functions that relate to each other. No, so here's the key. Here's the key. What I am asking for is not a definition of object and class. I'm talking about a definition or description of object-oriented programming. Okay, James? Um, Besides the fact that if I say an object is a repeatable collection of variables and functions that relate to each other, and a class is a way to show how those variables are and how those functions work, I would say, oh, yeah, no, we had that in C. We called that a program, right? You with me, James? I'm gonna just mock you and move on. Not mocking. No, you see what I'm getting at, James? Riley said, in essence, okay. Riley's getting super crispy hot. Um, in essence, object-oriented programming is the grouping of data and operations that can be done on that data together. Ding, 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 ding. Yeah. No, Riley's drilling right into the heart of the issue. Okay? Heart of the issue. Good job, Riley. Riley wins the chat so far. Craig, a method of organizing code which allows it to be more concise, as well as easier to understand and navigate. No, you might say it's prettier, but pretty is not the definition of object-oriented. Does you see what I mean? You see what I mean, Craig? Um, it might be more concise and it might be more understandable, but that's not the definition of object-oriented. You could point to a lot of things that aren't object-oriented programming and match that same definition. Wes, a way of programming that's falling out of favor to better ideologies such as functional programming. You bigot, you zealot, you overzealous, blankety blank. No, yeah, Wes. No, I'm just gonna just put it in a meme. Essentially, that's just meme speak, Wes. Um, No, I know. It's not a definition of object oriented. You know what I mean? It's a sales pitch for functional. And by the way, I have to say that there are certain. No, I'm just messing, Wes. I mean, it's what I'm saying technically is true. It's not a definition of object oriented, but I'm obviously just messing with you, um, mocking your zeal. No, the functional programmers tend to possess a great deal of zeal, and there are functional programming moments that are kind of exhilarating in my experience. So anyway, no, I like the chutzpah, Wes. I like it. Okay, Craig said audio. Are we still audio struggling? My mouse is happy. We're back good. Okay, all right. Um, Mike said object-oriented programming isn't going away, though. It's just not being abused to do gross things as much anymore. That's probably true. And part of that is the evolution of not only other programming languages, but a sort of a world that is multi-paradigm by its nature. James. Yeah, so James said, I feel Riley said the same thing or what I meant to say, just in a different way. I think he said what you meant to say, but it's critical. What Riley said that was critical was that the data and the methods are bunched together. Okay? That is huge. And in all fairness, James, you didn't say that. But you said you said one of the byproducts, it's easier to navigate, etc., or that it's more concise, but that doesn't say, because you have to understand that before object-oriented programming, you just had variables, global variables. You had some scoping. You had local variables, but you had global variables. And if you had a bunch of, and this is really important, if you had a bunch of, say, and I remember writing I remember it was a maps program or something in the 80s in Pascal. And there was a structure which defined the elaborate structure that was I can't remember if it was a linked list of these structures, but there was a structure, okay, with a bunch of fields. And then I remember there came a point, and everybody who touched the structure had to know what the fundamental organizational internals of the structure were. You had to know what the internals of the structure were. To parse it, to print it, to add one, to delete one, you had to know the internal structure. So the variable, the variable of the entire thing was a global variable, but the definition was a global concept as well. Okay, in essence, the class itself, but it wasn't. It was a structure. The structure was global, and then what happens is something that imperative programming was famous for, which was side effects. And what we mean by side effects is you would go to, here's an example. I've got something that traverses the list and does certain things. And then I change the structure. I now have to go look at every single place in the entire code that talks about that structure, that uses the structure, that references, to fix it so it's not broken everywhere. Okay? With object-oriented programming, that structure would be the data portion of an object class, a class definition, then later on of the object itself. And then all the methods that operate on it would be tucked right there. Everybody else would just call the method to do the thing. So I only would have to change the code once in the method where it got changed, and the rest of my code stays the same. It's a principle that was called information hiding. Okay, it was also called modularization. It was called encapsulation. It was called a number of things, but information hiding was the big one. It was a term coined by a researcher by the name of David Parnas, Parnas. But the idea was everybody doesn't see everything all the time. It was encapsulated by putting the data and the methods that work on that data in a bundle together. So when I make one, I make it all together. Now, this is the reason that I asked the question, is it's really hard when you've grown up with a certain world that's just the world and you don't really think about it any differently. In other words, the fish doesn't know that it is swimming in water. It doesn't know it's swimming, and it doesn't know it's in water. We are, for the most part, unaware that we are surrounded by atmosphere, oxygen, nitrogen, other gases, right, that we inhale. We don't really think about the fact that we're surrounded by these gases without which we die. All right. Okay. So I want to try to take something that you might just take for granted, but make it more explicit, where you actually have to explain it, where you have to actually think about it. Okay. Yeah. Okay. Back to James. Here's the problem again with variables and functions. Imperative program had variables and functions. What you didn't say, and it wasn't about data or operations. What you didn't say, James, is put them together and encapsulate them. That's what you didn't say. That's the missing part. Imperative programming and object-oriented programming have data and operations on that data. The difference is that object-oriented programming defines a thing called an object. And where does it define it? In a class is where it defines an object by declaring certain data and then setting up methods that can be called, some of them which can be called from the outside of the object once it's created. Okay, are we, James, you tracking? But here's, no, so Anthony, I'm going to call you out, man. No, not basically the same thing. A program in C is a collection of variables and functions that relate to each other. It didn't say it. Are you with me? I'm not backing down here. Okay. Anthony, I know you're James, attorney now, but no, it's the collections too broad. I'm trying to be as clear as I can be in articulating the issue to mitigate confusion. Does that make sense? To make sure that we are being as surgically precise as we, I'm not trying to be mean to James or Anthony. I just want to be explicitly, clear and as precise as possible in our choice of words. Okay. Wes asks, it's like abstractions, similar of real world things and how they have discrete properties, right? Yeah, yeah. In fact, the earliest pre-object oriented programming, there was actually a thing. They before we called them objects and classes, they were referred to. I don't know if you know this, Wes, but they were referred to as abstract data types, ADTs, abstract data types. But the idea was the encapsulation, the bringing together of, and again back to Kevin and James, bringing back to this idea that I take the data, I take the methods, I stick them together, and I put a wrapper around them, and I call it an object. That's kind of key. That's the key. Um, And before that, yeah, Craig is right. Before that, they were referred to as platonic forms. No, yeah, that's like the higher level, right? But classes are more like platonic forms. It's actually true. That's actually true. Okay. All right. Okay. So tired. Always tired. Objects are okay. So Gunner asks, objects are the rubber band around the collection. I would say that objects are the collection and the rubber band. Object-oriented programming, the data itself can be anything. The methods themselves the methods can be functional. The methods can be imperative. There's not really such a thing as an object-oriented method because the methods themselves can partake of any number of, the methods could be some kind of encapsulated SQL. They could be Python scripts. They could be Fortran. They could be ML. That's as in ML, the language, not machine learning. It could be Haskell. There's a language I grew to hate. I have stories. I was beat up in grad school by Haskell. No, you know what I mean? The methods themselves can partake of different programming paradigms, but they get encapsulated with the data. A wrapper, that's an object. It's a class when it's defined. It's an object when it's instantiated. I think we've made a lot of progress this week. Oh, and what did I say? Let's find out whether I suck or the degree to which I suck. Everybody sucks at least some, right? Let's see. Okay, object-oriented programming. I'm making a beeline for it. Sorry, I'm scanning down to page 59. Let's see what Dr. K said when I was a grad student. It's not bad. All right, let me throw this over here, and I'll try to blow this up a little bit so you can. Interestingly, in your chapter that you should have already hit by now, remember Liskov and the Liskov substitution principle? Well, there's me citing Liskov in my dissertation. Man, I was smart back then. What happened to me? Okay, so check it out. Some of the earliest efforts to improve imperative programming attempted to eliminate side effects and introduce more natural modularity. Some of the earliest work, Liskov, Zills, abstract data types. Conceptually, an ADT can be viewed as a tuple consisting of data objects and the operations that can be performed on them. In imperative design, data types and declarations are used to represent items in the real world that need to be modeled, while procedures and instructions operate on the data. In the ADT model, aka the object-oriented model, items in the real world are modeled as objects and consist of both data and the operations that can be performed on them. In this way, they are encapsulated and information is carefully contained within the context in which it is used. So again, back to James, when you're like, I said container, container is really broad. If I say they're contained within the context in which they're used, it's also other words around it. Parness, I mentioned parness, information hiding, to describe the concept that information should be hidden from other parts of the program in order to eliminate unwanted side effects. And then we go into a little bit of a history of object-oriented programming, Simula, Algol, Smalltalk, Ada, Modula 2, Objective-C, et cetera, et cetera. And again, I don't think I cite, no, it's interesting. I do cite to Java in this dissertation, but as a language, it was less than a year old when I did it. Let me see. Yeah, so notice, now this is an interesting exercise because this was my dissertation and I was using Alexander's sort of form for the most part, where I said, object-oriented program was a pattern. Think of it that way. What's the motivation? There have always been serious limitations. So I'm kind of laying out the motivation. And then there's a discussion that kind of walks through some of that and kind of articulates it. Object class is a pattern where I'm citing Liskov and Parnas, principles of encapsulation, some discussion about it, and then some examples about it, patterns that are above it, patterns that are below it, and other related patterns. I think I did okay. I think I did all right. Inheritance as a pattern. Oh yeah, look at me rocking. That was pre-UML, by the way. This was before UML existed. Um, anyway, yeah. No, I'm going to stand by my dissertation here. That wasn't bad, was it? I mean, I'm not, that was written by, my dissertation seeds is 309 pages. You can see up there. The crazy thing about my dissertation, actually, is I got to get to the bottom to show you. The references start right here on page 279. So the references alone, starting here, 279 to 309, that's 31 pages of references. And yes, I did read all of that. Oh, and I managed somehow to cite myself 7 times. But that one's actually a pub. These others are technical reports, but I did manage to cite myself 7 times. Um, anyway, yeah. Um, yeah. So, yeah, Tyson, you know, you have to be motivated, right, to write a 300-page essay so they can call you Dr. K. Okay, back to Kevin. Um, yeah, Gunner, a rubber band ball. No, but it's still not a rubber band ball. It's a rubber band. It's more like a golf ball, which original golf balls, some golf balls have a core, like a certain kind of a core material with rubber bands wrapped around that core, and then a hard shell put over it, more like that. Kevin, ADTs were more than struct. Yes, yes, they were like structs with weird function pointers. Yeah, yeah, right. Um, no, okay. I like what Kevin's saying about. Thank you. That's a solid ball, but look for one with rubber bands. There are two different kinds of golf balls. This is a solid ball, but there were, and I don't know if it's state of the art anymore, but when I was a kid, we used to cut golf balls open and unwind the rubber bands and get down to this sort of interior, which was filled with a fluid. This probably explains. Um, no, James, no, that can work. That can still work. But except you got to lose the rubber band idea if we say golf ball, because the solid golf ball doesn't have rubber bands. That's all I'm getting at. No, Kevin, I think the idea of having this, because this you can write that in the code, but it doesn't make any sense until you instantiate, right, Kevin? I think you're tracking, right? On trying to drill into what you're saying, which I think is kind of insightful. That when you have right this and self-reference, um, as opposed to, well, but also you have the name of some variable that is an object, that thing dot its methods. That's what we're invoking. We write our code that way, but it doesn't do anything until we're running and that object exists. Okay. Um, Classes have static members. I think objects do too, Kevin. Yeah, objects do too. But the static members are declared in the object. Sorry, in the class. They're instantiated and running in the object. Okay, where are we at here? Okay, I think this has been valuable, right? I mean, absolutely dependent on language implementation. I'll buy what you're selling right there, Kevin. Um, I hope this isn't like a total waste. I hope this is because we're going to talk about object-oriented design, but you understand that when we look at like the design patterns, um, so Tyson, you got to define access. Okay. Oh, great. Throw code at me. What do you guys think? What do you guys think? I don't tend to think in code, by the way, just FYI. Some of you really do think in code, and I don't. So I always have to stop and go, okay, what language, what syntax, what's particular, um, strength and weakness, right? No, I don't think you can say in general object.static member plus equals 1. I think you've got to start by pulling it out. Now it's a value, you can increment it, but you can't change it. But unless I'm wrong about that. But again, it depends on the definition of a static member. Anyway, I think it depends on the language, like Kevin said. Um, but I don't know. I don't know the sort of the abstract answer to that. I would say yes, that objects can have static members that can be defined, they can be used, they just can't be changed. And I can be wrong. Okay. Yeah, JavaScript and live life happily. Oh, Tyson. That's even worse. Who made the functional comment? That's even worse. JavaScript. I don't know. Yeah, assembly, so there's no confusion. There's also no productivity, Craig, right? Um, okay, yeah. No, Wes, I know. We know you were joking. Um, alrighty. So, where we're gonna go with all this thing, I want to get to slide number 2 at least before spring break. Yeah. All right. Just talk about this for a couple minutes. Class diagrams because we have classes. Okay, and this is the thing I want to say. When Goff came out, it was called design patterns. But what it should have been called, in my humble opinion, is um, object-oriented idiomatic patterns in C++. That's what I thought the book, if it were truth in advertising, that's what it should have been called. Object-oriented idiomatic patterns in C++. Okay. And this is important because it's object-oriented design patterns. These are not universal design. First of all, they're also more idiomatic than design, frankly, my opinion. But there are patterns, powerful patterns for functional programming, and powerful patterns for imperative programming, and for database programming. You know, and for markup language programming. They're different patterns. And so these are not like the patterns, they're object-oriented patterns. And if object-oriented programming ever goes away, which it will go away, I believe. It's not eternal, okay, and timeless. When object-oriented patterns go away, then those design patterns won't be worth anything. Now, it'll take a long time, I think, but imperative programming existed for a very long time, and then it gave way to object-oriented programming. So what comes next? I know, functional, right? Right, Wes? Whoever said it. Yeah. Anyway, Gunnar, I love C, man. I wrote a lot of good, solid code in C. Um, collection. Yeah, my beard is eternal. I think it's possible. All right, man. So we're about out, but yeah, but this is okay. I want to just say this. I remember I was in a class at BYU as an undergrad, and one of my professors was Evan Ivy, and he was kind of legendary. He was the development manager at Bell Labs, whose group created the C programming language and the Unix operating system. Okay, that was his group. He was part of that. He hired Brian Kernighan. He hired Dennis Ritchie at Bell Labs. Okay, Kernighan and Ritchie were the inventors of the C programming language. And I remember him just saying, so in 20 years, when you're writing whatever it is you're writing your programs in at that point, I don't know what it will be, but it won't be C. And C was the shiz, okay? And I remember just sitting there just going, wait, this is the inventor, the grandfather of the inventors of C. And he's saying, I don't know what it will be, but it won't be C. And he was right on balance, right? I mean, a few exceptions, but he was right. And I remember just realizing that because you grow up and you think whatever they're teaching you in school is like the shiz, the thing, and then you just have to kind of realize, no, a thing, a shiz, not the shiz, a shiz, a thing. And value will probably always be there, but it's going to give way to something else that's going to, that was not obvious until it was. So just understand, this stuff's not permanent. He was thinking of JavaScript. Um, Mike, that's because you're a computer engineering major. Um, Anyway, yeah. Alrighty. So we're going to come back on slide number 2 after spring break. And good luck with everything. That's all I got for today. Adios. Arrivederci. Ciao tutti. Yeah, Kevin Rust is going to win. Just FYI for everybody. It's going to be Rust when it's over. Natively multi-paradigm programming language. All right, my friends, I'm out.